Welcome back, students. In today's class we will learn how to evaluate integral b to infinity dx divided by ax squared positive x squared. Now you have to know a very important property, which is if you are given, say, integral a to infinity of f of x times dx, then this can be rewritten as, say, limit t tending to infinity of integral a to t f of x times dx. Now this can be rewritten as limit t tending to infinity of f of t negative f of a, which is nothing but integral f of x times dx. The limits are from a to infinity. Now you don't need to learn or you don't need to understand all of these. You just know that integral a to infinity f of x of dx is nothing but integral f of x times dx, and the limits are a to infinity. So this is from calculus. It's a property there. Now since we are given this integral in b to infinity dx divided by ax squared, I'm going to consider it first. Integral b to infinity dx divided by ax squared positive x squared, and then rewrite it as integral dx divided by a squared positive x squared. The limits are from b to infinity. Now we already know that integral dx divided by a squared positive x squared is nothing but tan inverse of x over a, with 1 over a being a constant, okay, plus c. Now if we were to use this formula, then we would get this quantity to be as 1 over a tan inverse of x divided by a. The limits are b to infinity. Now applying limits, we get so this is going to be, substitute the upper limit, 1 over a is constant. I can take it out and rewrite this as tan inverse of infinity divided by a negative, substitute the lower limit, tan inverse of b divided by a. Okay. Now tan inverse of infinity. Okay. What is tan inverse of infinity? This is going to be equal to pi divided by 2. Now why do I say this is pi divided by 2? I can rewrite this to be as tan of pi over 2. Now what is tan of pi over 2? It's nothing but sine pi over 2 divided by cos pi over 2. So sine pi over 2 is 1, but cos pi over 2 is 0. So 1 over 0 gives us infinity. Now since we know this, therefore if I were to take this as 1, I can now say, therefore 1 now becomes, I got 1 over a times tan inverse of infinity divided by a. Doesn't matter what is the denominator. We are going to get pi divided by 2 negative tan inverse of b divided by a. Now this is the result for integral b to infinity dx divided by a squared positive x squared. This is a very important result that you will have to know and understand. Now since we have got this, suppose you are given a question like this, say evaluate integral 0 to infinity dx divided by a squared positive x squared. They want you to know the answer to this question. Now this is very simple to do, because we know that, since we know that integral b to infinity dx divided by a squared positive x squared is nothing but 1 over a pi over 2 negative tan inverse of b divided by a. Okay, so you have to remember this output. So in the place of b we got 0. So this would mean we now have 1 over a times pi over 2 negative tan inverse of, don't substitute b there, in the place of b we have got 0, so that's going to be 0 divided by a. Now we have got tan inverse of 0. Now what is tan inverse of 0? We know that tan inverse of 0 is going to be equal to 0. So because we know this clearly, this is going to get cancelled. So we would now have pi divided by 2 times a. On the left, it's nothing but integral 0 to infinity dx divided by a squared positive x squared. What you can do is you can box the result. Okay, boxing the answer is a very good way of representing the solution so that your examiner will know that you have got the final answer. Now, having done this, let us move on to next question. Say, suppose you are asked to evaluate integral a to infinity dx divided by a squared positive x squared. So this is the question that they have given you. So what you need to do? Now you need to start like this. Since we know that integral b to infinity dx divided by a squared positive x squared is equal to 1 over a times pi over 2 negative tan inverse of b divided by a, and then write hence. This is a good way of using this word, hence integral a to infinity dx divided by a squared positive x squared is now going to be 1 over a times pi over 2 negative tan inverse of, in the place of b you got a, so substitute a and then close the parenthesis. So a and a going to get cancelled, so that would give you 1 over a times pi over 2 negative tan inverse of 1. Now we know that tan inverse of 1 is pi over 4. Okay, since we know that tan inverse of 1 is pi over 4, the final answer is going to be 1 over a times pi over 2 negative pi over 4. Now you can take the LCM as 4. Of course you have 1 over a as a constant there. So that would give you 2 pi negative pi, the final answer being pi divided by 4 times a. So you can write the final output integral, therefore integral a to infinity dx divided by a squared positive x squared is equal to pi over 4a. So this is the solution for this question. Now we can still further go and do the next question. So we have here integral negative infinity to infinity dx divided by a squared positive x squared. So what you can do is, since we know that integral b to infinity dx divided by a squared positive x squared is equal to 1 over a of pi over 2 negative tan inverse of b divided by a, hence the question integral negative infinity to infinity dx divided by a squared positive x squared can be rewritten. Now before I could substitute this, what I'm going to do, I'm going to rewrite this as 2 times integral 0 to infinity dx divided by a squared positive x squared. Now why do I do that? Because I know a property. If given integral f of x times dx, the limits are negative a to a, I can rewrite this as 2 times integral 0 to a f of x times dx if f of x is an even function. Okay, now clearly in this case 1 divided by a squared. Now since you can say f of x is equal to 1 over a squared positive x squared is an even function, hence we have, so what do we have? Integral negative infinity to infinity dx divided by a squared positive x squared can be rewritten as 2 times 0 to infinity dx divided by a squared positive x squared. Now in this case I would be substituting this formula which we already know. Okay, so that means I can rewrite this to be as 1 over a times pi divided by 2 negative tan inverse of, in the place of b we got 0, so substitute 0 divided by a. Now this entire thing has to be multiplied by 2. So this is going to be 2 over a times pi over 2. Now clearly if you see tan inverse of 0, now what would you get when you take tan inverse of 0? That is going to be 0. So this is going to get cancelled. So you would only left with 2 pi divided by 2 times a, where the 2's can be cancelled, giving you pi over a. So you can write the final answer. Therefore, integral negative infinity to infinity dx divided by a squared positive x squared is equal to pi divided by a. And you block the final answer.